Hello students, welcome to the EPG Pathshala. I am Dr. Sanjay Kumar Chamoli from Department of Physics and Astrophysics, University of Delhi. Today we are going to discuss about a module, Introduction to the Nucleophilics, under paper Nuclear and Particle Physics. So students, let us see what we are going to learn in this module. First, the importance of learning nucleophysics. Second, the understanding of development of nucleophilics. And third one, the knowledge of basic terminology and various units used in the nucleophilics. First important question comes in this particular module is that why to study nucleophilics? What is so important? What is so fascinating about nucleophilics? So here are few examples that why you should study nucleophilics. First of all, to understand the origin of elements, like how our world was created, how all the elements present in our universe was created, Big Bang theory of the universe, where the earliest metal were synthesized, and after that we will move into the heavier elements, and in this journey all these elements were synthesized because of the nucleophilics. When the stars were made, then the elements up to iron were synthesized into them. Then in the more mature stars, some exotic phenomena like supernova happened, and in that case the heavier element or the elements heavier than iron were synthesized. So in order to understand all these things, we need to understand or we need to study nucleophilics. Second one, to understand the origin of various properties of elements. In the coming lectures, we will see that the nuclei possess very many properties which are fundamental to them, and the properties like mass, charge, spin, etc. And these properties have various applications in common life. So we need to understand the origin of these properties in nuclei. Third one, to understand the origin of forces in the universe. That is towards unification of forces. We know that our world is created with four fundamental forces in nature. That is, with four fundamental forces: the gravitational force, the electromagnetic force, the weak force, and the strong force. And how these different forces have come into existence, that we have to understand. And also, is there some way by which all these four forces can be clubbed together into a single force, which we can say that unification of forces? In order to understand that, we need to basically study nucleophilics. And in the last, which I have included, that to improve the quality of life on Earth. As I told you, that nowadays we are living in the materialistic world. And in this materialistic world, whatever aspect of life you talk about, in those aspects, whatever material things we basically use, in all those material things, at some point of time or in some form or other, the nucleophilics is involved. For example, the nuclear fission for energy generation. That means the electricity that we are using nowadays, in some way the electricity can be generated through nuclear processes also in nuclear reactors. So this thing basically, to understand how the electricity is produced in the nuclear fission process, we need to understand nucleophilics. Also, use of radiation technology in medical field, industry, agriculture also. So there are variety of applications which involve the nuclear isotopes or radioactive isotopes, for which or not only radioactive isotopes. In addition to radioactive isotopes, some nuclear measurement techniques are also being used. So to understand and to make use of these nuclear techniques, we need to study nucleophilics. If we go into the history of nucleophilics, then we find that the nucleophilics really started after the discovery of nucleus by Rutherford. In some sense, we can say that Rutherford's discovery was the discovery of nucleus by Rutherford was an accidental discovery, because he was trying to modify the Bohr's atomic model, and in that process whatever experiment he performed, when he did the analysis of that experiment, then he found, then he discovered basically the nucleus. So on this slide, basically on the left hand side, we have the schematic of the experimental setup used by Rutherford, and on the right hand side, we have the picture of Ernest Rutherford. So in the experimental setup, what he did was basically he used the energetic alpha particles, and he bombarded those energetic alpha particles to the gold foil, and then whatever scattered alpha particles he could obtain at various angles, he basically detected them with the help of some scintillators, and then he analyzed those detections. So what he found is basically after in the analysis, what he found is that most of the alpha particles basically were undeviated after passing through the gold foil. There were few alpha particles which were scattered at an angle, at a certain angle, with respect to the initial direction of alpha particle, and he could find very few number of particles which were basically backscattered. All these alpha particles he found on the scintillator detector placed at various angles. So when he plotted the number of alpha particles detected at various angles as a function of angle, then he found very interesting observations, and he basically concluded on the basis of those analysis, he basically derived certain conclusions. The first conclusion he drew is that most part of the atom is basically empty in nature, and there is a central entity in every atom, basically where which is a positively charged particle, which is positively charged, because as he could find that alpha particles were positively charged, and a positive charge basically can be repelled or scattered only by a positive charge. So on the basis of this, he could find, since he could detect the alpha particles at various angles, so he basically considered that the central entity which is scattering the alpha particles must be of positive nature, and on the basis of that, he basically named that central entity as the nucleus, because it was in the center of the atom. So he named it nucleus, and then he considered that nucleus is basically a positively charged. Positively charged. Another thing he considered is, on the basis of experiment, another thing he considered is that almost all the mass of the atom lies in its center, that is, in the central entity he named as nucleus. So he considered that almost 99.99% mass of the atom is concentrated only in this central entity called nucleus. So basically he basically came across the term nucleus, and then after that, whatever basically the study we have about the nucleus, that study basically was started after the discovery of nucleus. Composition of nucleus, the issue of electron. Now, after the discovery of radioactivity by Henry Becquerel in 1896, it was thought that the nucleus is composed of a number of protons and n number of electrons. The argument explained beta radioactivity, but it was wrong. Now, one of the important things that we should understand, that when radioactivity was discovered, people thought that there are only three particles coming out of the nucleus, that is alpha particle, beta particle, and gamma radiations. And then, since there was no concept of neutron, which was later on discovered in 1932 by Chadwick, so since there was no consideration of neutron, so after the discovery of nucleus by Ernest Rutherford, it was thought that nucleus is composed of two particles called protons and electrons. Now, why that was considered is because there was no neutron, and second thing, only two particles coming out of the nucleus in the radioactivity were seen by the people. So people thought that nucleus is composed of protons and electrons, and the charge in the nucleus is equivalent to the total number of protons present within the nucleus. This theory of this electron proton theory of nucleus could easily explain the radioactivity, because in the radioactivity people have basically detected electrons coming out, which was basically beta particle. So beta particles, which were basically electrons coming out of the nucleus. So people thought that electron must be within the nucleus. So they could easily explain the radioactivity. But this theory was horribly wrong due to the following reasons. First reason was electrons cannot reside inside the nucleus due to the Heisenberg uncertainty principle. Now Heisenberg postulated that in any quantum system, the uncertainty related to the size and the uncertainty related to the product of uncertainty related in the measurement of size or the position and the uncertainty related to measuring momentum of the particle is equivalent to h upon 2 pi, is of the order of h upon 2 pi. That is, if the size of the nucleus is of the order of Fermi, so uncertainty related, that is delta x, is equal to 10 to the power minus 15 meter. From uncertainty principle, delta p into delta x is around h bar, which is equal to h upon 2 pi. So delta p can be estimated to be around h bar upon delta x. H bar, since h bar is equal to h upon 2 pi, where h is the Planck's constant. So if we put the value of Planck constant divided by 2 pi and the value of delta x, which is of the order of 10 to the power minus 15, so we get the energy value as around 98 MeV. So in the previous slide, we found that the momentum, if the electron has to be within the nucleus, then the momentum should be of the order of 98 MeV. Now when we convert this momentum into energy, we have a relation as E is equal to square root of m0 square, where m0 is the rest mass energy of rest mass of the electron, plus delta p square. So when we convert this, then we found that energy comes out to be around 98 MeV. So kinetic energy of the electron, which is equal to the total energy of the electron minus the rest mass energy of the electron, will be equal to 98 MeV minus 0.511 MeV, that is almost equal to the same value, that is 98 MeV. So for an electron to be within the nucleus, its energy has to be more than 100 MeV. However, the average energy of beta particles coming out of the nucleus is around 1 MeV. So this is the highest energy ever observed for any beta particle coming out of the nucleus. So since the energy requirement for electron to be within the nucleus is of the order of 100 MeV, but the detected beta particles, the maximum energy of the detected beta particles coming out of the nucleus is around 1 MeV, is hugely different. So it is thought that on the basis of Heisenberg uncertainty principle, it is impossible for the electron to be inside the nucleus. Now next reason that why proton-electron theory was discarded was due to the violation of angular momentum rule. Now angular momentum is nothing but the total spin of the nucleus. Now for neutron, we find that there are total number of nucleons equal to 2, in which if the proton-electron theory has to be believed, then there is one proton and 2 electrons. Mass is equal to 2 and Z is equal to 1. That is, number of proton is equal to 1. So there should be 2 protons and an electron inside the nucleus. As in the deuterium nucleus, there are 2 protons and 1 electron, and we know that the proton electrons are fermionic particles, so they are a spin half particle. So when we consider their intrinsic spin, then for 2 protons, the spin, according to Pauli exclusion principle, they will be half plus half. For 1 electron, it will be half. So possible spins of neutron will be 1 by 2 plus 1 by 2 for protons plus 1 by 2 for electron. That is, either the value will be half or 3 by 2. This half value is because inside the nucleus, the two protons basically will be paired up with a spin direction opposite to each other. So they may cancel out. So total spin related to the protons will be 0, plus 1 by 2 is the spin related to the electron. So the first value of the resultant spin is 1 by 2. 3 by 2 is if we consider that the two protons are parallel to each other, they are in different states, so it means the total spin is equal to 1, and then plus 1 by 2, that is equal to 3 by 2 spin. So but the measured spin of neutron is 1 h bar. So it clearly shows that if we believe that the electrons are inside the nucleus, or if we believe that proton-neutron theory of nucleus is correct, then the electron spin has to be either 1 by 2 or 3 by 2, but experimentally the neutron spin is measured to be 1 h bar, which is integral spin. So on the basis of this addition of angular momentum also, we can say that the proton-electron theory was not possible. Reason 3 means third reason that why the electrons cannot reside inside the nucleus is on the basis of the magnetic moment value of the nucleus. So in the expression we have seen that the magnetic dipole moment depends upon the mass. If we are talking about the magnetic moment of atom, then we use the mass of electron. But when we talk about the magnetic moment of the nucleus, then we make use of the mass of proton or neutron. Now as the mass of proton is 1837 times the mass of the electron, so when we put in order to calculate the magnetic dipole moment of nucleus, when we put the mass of proton, we find that the magnetic dipole moment for the nucleus is roughly 1 upon 1837 times the magnetic dipole moment for atom. So it means if the atom has to be within the nucleus, then its magnetic moment, then the magnetic moment of the nucleus must be comparable to the magnetic dipole moment of atom. But this is not the case. Experimentally also, nuclear magnetic moments are found to have very, very small value. So as the measured magnetic moment of nuclei are very much less than the magnetic moment of electron, so the electron cannot reside inside the nucleus. Next important reason that why the electron cannot reside inside the nucleus is the stability of nucleus with both proton and electron inside. This is an issue because electron is negatively charged, proton is positively charged. So if these two particles are within the nucleus, then definitely Coulombic force will attract them and the nucleus cannot survive because the proton and neutron will collapse, and in that case the whole nucleus will collapse. So if electron has to be within the nucleus, then a very strong force, even stronger than the electromagnetic force, would be needed to bound them. Yet no evidence of any strong force between the proton and atomic electrons exist. Composition of nucleus, discovery of neutron. So as in the previous slides, we have seen previous theory of electron-proton inside the nucleus was having some serious consequences and could not be justified on the basis of various issues. So people started looking beyond that theory, and in that process the neutron was discovered. Now the discovery of neutron basically can be related to two important experiments. First, by Joliot and Curie in Paris in 1925. In this experiment, what they did, basically they bombarded the beryllium foil with energetic alpha particles, and then they found that the reaction was like alpha particle, that is helium at doubly ionized helium nucleus plus beryllium will give you 12 carbon plus 6 plus 1 neutron. Now what they did on the left hand side we have the schematic of the setup they used. So in the schematic it is clear that the alpha particles are coming from the box, they are hitting the beryllium foil, and then after hitting the beryllium foil, whatever things are produced, whatever radiations or particles are produced, they are hitting the paraffin, the foil of paraffin, the slab of paraffin. Paraffin means wax, And then after that, whatever is coming out, they detected it with the help of some electrical setup, with the help of some detector. So now what they concluded on the basis of this, whatever they have collected in the detector, they concluded something. Juliet and Curie showed that this radiation, means which is emitted out of the reaction of alpha particle with beryllium, was able to knock protons out of paraffin, but they misinterpreted the process as scattering of gamma rays on protons, similar to the Compton effect, scattering of gamma ray on electrons. Because the Compton effect was discovered much before the discovery of neutrons, so they basically thought that the invisible radiation which is coming out of the beryllium foil after having due to the reaction of alpha particle with beryllium, they thought that these are basically the energetic gamma. This radiation is basically the energetic gamma ray, and this energetic gamma ray is basically this energetic gamma ray is knocking out the protons from the paraffin, similar to what we have seen in case of Compton effect, that the gamma rays basically knock out electrons from the orbit in an atom. Composition of nucleus, discovery of nucleon. So this slide is in continuation to the previous slide. In the previous slide, we could see that Joliet and Curie performed an experiment and they obtained some results, and on the basis of the results, they equated the invisible particle coming out of their experiment as equivalent to as the gamma energetic gamma rays, and basically they considered that these gamma rays are energetic enough to emit protons, similar to what the people have seen in case of Compton effect. Now Chadwick in Cambridge in 1932, he also did the same experiment, but he did a small change in it. He used the same reaction, that is alpha particles. On the left hand side, you can see in the block diagram, you can see that the experimental setup has been given. So he basically there is a chamber in which the polonium source is there, which is a source of alpha particle, and then the beryllium slab is there, beryllium foil is there. So alpha particles hit the beryllium foil, and then the invisible radiations come out, and then again he used the paraffin wax slab, and after the paraffin wax slab, whatever is coming out, whatever radiations or particles are coming out, they have been detected by the ionization chamber. Now what smart move Chadwick did as compared to the previous experiment, that every time he replaced this paraffin by several other materials, and then he basically detected the radiations, and on the basis of that he concluded something. So the first important difference between the earlier experiments and the Chadwick experiment is that Chadwick used ionization chamber to measure ionization and the length of the track. Then he used several materials, hydrogen, helium, lithium, etc., on the way of radiation from beryllium. So this was an important difference. Then particles ejected from hydrogen. The particles ejected from hydrogen were like protons with a speed of 3.2 in 10 to the power 9 centimeter per second. So remember, in the previously people used paraffin wax all the time, but Chadwick removed this paraffin wax slab by several other materials, that is hydrogen, helium, lithium, and in that process he found that the particles ejected from the hydrogen were like protons with a speed 3.2 in 10 to the power 9 centimeter. Now he also concluded that when he replaced the foil by heavier materials like helium, lithium, etc., he found that particles ejected from heavier targets had larger ionizing power and were in each case recoil ions of the element. So this was a very important observation he made. So students, as we have seen that Chadwick used the same experimental conditions as used by the other researchers prior to him, except with few differences, like he used the slabs of many different materials to test the interaction of the invisible radiation with matter, and second thing, he used ionization chamber to detect the outcome of that reaction, and he specifically detected proton with a speed of 3.2 in 10 to the power 9 centimeter. So then on the basis of his observation, basically he basically analyzed the result, and then he concluded that if a proton is ejected due to the scattering of photon on nucleus, then to speed it up to 3.2 in 10 to the power 9 centimeter per second, a 52 MeV photon is needed. This is very important, and this exceeded all known energies of photon emitted by nuclei. It means the maximum known energy, whatever is emitted from a nucleus, was very much less than the energy of the photon required to emit one proton from the wax slab. So it means it was impossible for a photon to emit a proton. Then if it was not photon, because it was invisible, that is why the people thought of photon. But if it is not photon, then what else? All difficulties disappeared when he assumed that the particle is a neutral one with mass identical to proton. So it means he, rather than considering rather than going in the same logic of considering it like photon, he termed it as that it's not a radiation photon like photon, but it is actually a particle, a neutral particle which is having the same mass as the mass of the proton, and then he named it as neutron because it was a neutral particle. And the existence of that neutral particle he proved mathematically also by his calculations. So Chadwick called this neutral particle as neutron in a letter to Nature in February 17, 1932. So he published his results in Nature Journal in February 17, 1932, and on the basis of this work, he was awarded the Nobel Prize in 1935. So after the Chadwick's discovery, nucleus composition, the nucleus got its composition as the neutron and proton inside it. Our understanding of the nuclei so far. Now, since the discovery of nucleus by Rutherford, very many number of nuclei have been discovered so far. In total, that is the data that I will be showing here is up to year 2010, that around 6,000 nuclei are predicted to exist, and out of these 6,000 nuclei, 3,000 have already been discovered. That is, they already exist in the universe, or they have been created under lab conditions. So 3,000 are the known number of nuclei, 6,000 are the total number of nuclei predicted by various theories or models. Now when we plot these nuclei, that is 6,000 nuclei, as a function of proton number, or in the plot of proton number versus neutron number, then we come across a chart which is called the Segre chart. Now in this Segre chart, we can find various interesting things. Now as you can see in the picture, we have a black dark dotted line in the center, which is called which shows basically the line in which all the stable nuclei are plotted. Then beyond means on the top of that line of stability, we have the proton drip line and the neutron drip line on the lower side. Now in between the proton drip line and the stable nucleus, there are unstable nuclei which are having more number of protons than neutrons, more number of protons than what is required for the stability of the nucleus. Also, on the lower side of line of stability, we have unstable nuclei which are having more number of neutrons than what is required for stability. So the proton drip line and the neutron drip line are the two bounding lines for all the nuclei which justified that beyond these lines no nucleus can be produced, or no nucleus can be produced means if we talk about the proton tripline, it means if we cannot produce a nucleus by putting an extra proton to it. Similarly, on the neutron tripline, if we pick one nucleus, then if we add one neutron to it, we cannot form another nucleus. So these are the limiting values for all the nuclei, for the nuclear existence. Now when we move up, then we found there are certain other interesting things, that is, we come across heavier nuclei and super heavy nuclei. So all these nuclei basically are predicted nuclei, but very few of them have been discovered so far. So students, in the study of nucleophysics, we will come across some very common terms which we need to understand what they mean. First of all, in the nucleophysics, quite often the term nuclide is used. Nuclide means a nuclear species with given proton and neutron number. Also, the term like isotopes is used. Isotopes means the nuclides of same Z but different values of N. Isotones means the nuclides of same N and different Z. Isobars means nuclides of same mass number A but different Z values. So all these terms we will get to know when we study nucleophysics. Also, there are some terms which will be used like isomer. Isomer means nuclide in an excited state with a measurable half-life. Then nucleon term will be used. Nucleon means neutron, either neutron or proton. Then positron is used. Positron means positively charged electron. Then sometimes we will use the term like meson. Mesons means particles of mass between electron and proton. And then quite often we will be using the term called photon. Photon is an electromagnetic radiation commonly apparent as light, X-ray or gamma ray. So these are very common, very familiar, very common term that will be or that are used in the study of nuclear physics. Basic units in nuclear physics. Now so far we have understood that nuclear physics is important and we need to study nuclear physics for a variety of reasons. Now when we study nuclear physics, then since we need to measure various properties of nuclei, so in order to define those properties in terms of some sensible numbers, we basically use some set of basic units. For example, in length, the nuclear lengths in nuclear physics are basically defined in terms of Fermi or femtometer, because the size of the nucleus is of the order of femtometer. Now conversion formula is 1 femtometer is equal to 10 to the power minus 15 meter. Energy is defined in terms of electron volt, and 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Other higher units to define energy in nuclear physics is keV, which is equal to 10 to the power 3 electron volt, MeV, which is equal to 10 to the power 6 electron volt, GeV 10 to the power 9 electron volt, TeV 10 to the power 12 electron volt. In the same way, mass is defined in terms of AMU, that is atomic mass unit. Conversion formula is 1 atomic mass unit is equal to 1.67 into 10 to the power minus 27 kg. Other higher units are 1 MeV per c square, that is equal to 1.78 into 10 to the power minus 30 kg. 1 GeV per c square, that is equal to 1.78 into 10 to the power minus 27 kg. It means the nuclear masses can be defined either in terms of AMU or MeV per c square. Now time in the nuclear physics basically is defined in terms of femtosecond, picosecond, nanosecond and microseconds. Now femtosecond is represented with Fs, picosecond is represented with Ps, nanosecond is represented with Ns and microsecond with μs. Now conversion formula is 1 femtosecond is equal to 10 to the power minus 7 minus 15 second. 1 ps means picosecond is equal to 10 to the power minus 12 second. 1 nanosecond is equal to 10 to the power minus 9 second. 1 microsecond is equal to 10 to the power minus 6 second. Now cross section is defined in terms of a special unit called barn. Conversion formula is 1 barn is equal to 10 to the power minus 28 meters square. So all these units are basic units of nucleophysics, and they are very useful in defining various values or the values of various nuclear properties in nucleophysics. So students, in the end, let us see what we have learned in this module. First of all, after going through this module, we understood that study of nuclear physics is important not only to understand the mysteries of the universe but also to improve the quality of life on Earth. Second thing, though radioactivity was discovered in 1996 by Henry Becquerel, but nucleophysics really started after the discovery of nucleus by Rutherford in 1911. Third thing that we have learned in this module, that the proton-electron theory of nucleus was discarded due to its inability to cope with the quantum mechanics, and the proton-neutron theory evolved after the discovery of neutron by Chadwick in 1932. Another important thing that we have learned from this module is that the knowledge of basic units and terminology used in nuclear physics is important. Thank you very much.